we are given a quadratic function of the form a times x minus h squared as a quantity plus k, then this is a parabola with the following characteristics. If a is greater than 0, the parabola opens up, and y equals k is the minimum value. Let's just draw a picture for this. A value means that it opens up, and therefore we have a minimum value. Versus if a is less than 0, then it opens downward, and we have a maximum value. The point h comma k, as given in this form, h comma k is the vertex of the parabola, and x equals k is the axis of symmetry. Because all parabolas have symmetry, we know we can find that based on the vertex. The vertex is the turning point. To graph a quadratic in standard form, we first determine the vertex of the parabola. Determine the vertex. That vertex is hk as an ordered pair. Determine whether the parabola opens upward or downward. If a is greater than 0, it opens upward. If a is less than 0, it opens downward. Next, we find any x-intercepts by solving the equation f of x equals 0. This will be a quadratic equation, so we can apply the techniques from a previous section. The function's real zeros are the x-intercepts. Then we find the y-intercept by computing f of 0. We let x equal 0. And then last, we plot the intercepts, the vertex, and any additional points that we have as necessary. Connect these into a smooth curve that is shaped like a bowl or an inverted bowl. Now let's graph two of these. Sketch the graph of the function below. F of x equals -2, parentheses, x minus 3, close parentheses, squared, plus 8. Now remember, the form is a times x minus h squared plus k. And hk is the vertex. So because we have minus 3 plus 8, that tells us that our vertex is the point 3, 8, that ordered pair. Let's go ahead and put that point on our graph, point 3, 8. And because that is our vertex, okay, our axis of symmetry will actually occur at that point. So our axis of symmetry is x equals 3. Now, to answer if this is a maximum or a minimum, we have to observe the a value. Our a is -2, which means this opens down. In fact, it has a stretch. It's reflected and has a stretch by 2. And let's see, plotting those points with a stretch included. I have those. So this is a maximum value. And the value of the maximum or minimum is 8, because our highest point is at 8. Go ahead and connect these in a smooth curve. Now the y-intercept, well, I don't know that. So let's find f of 0. That would be -2 times 0 minus 3 squared plus 8. Well, 0 minus 3 is -3, so we have -3 squared times -2 plus 8. Well, -3 squared is 9, so this would be minus 18 plus 8, or minus 10. So the y-intercept is the point 0 minus 10. Now our domain, because this is a polynomial, even though it's written in this vertex form, it is a polynomial, so the domain is all real numbers, or minus infinity to positive infinity. And the range, because it opens downward, is from minus infinity up to positive 8, including that positive 8. Let's look at one more example of this process. Again, we want to look at our vertex form, a times x minus h squared plus k. Now, because we have here a plus 4, if you think back to transformations, that means you go to the left 4. That would be negative. So our vertex is -4, 6. it's the opposite of what occurs in the parentheses, the x minus h, because that formula does have, or that form does have a minus sign already. So -4, +6, with an a value of 3, which means there is a stretch, and because a is positive, it's stretched up. So 1, 2, 3. So we have a point at -3, 9 and -5, 9. Connect these with a smooth curve somewhat. The axis of symmetry occurs at that point, so x equals -4. It appears that we have a minimum value, and that minimum is +6 because that is the lowest point that our function gets to. That is part of our range as well. Let's just go ahead and do that. The range is going to be from including +6 to +infinity because it opens up. The domain, well, this is a polynomial, again, in a different form, but a polynomial nonetheless. So -infinity to +infinity. And our y-intercept, we will evaluate this at 0. F of 0 equals 3 times 0 plus 4 squared plus 6. Well, this segment here, 0 plus 4, that's 4. Squared is 16. So we have 3 times 16 plus 6. 3 times 16 is 48. Plus 6 is 54. So the y-intercept is the point 0, 54.